Hello.
Hello. Hey. How's everyone doing today?
Pretty good. Enjoying my reading week. It's so nice.
Yeah. No, I completely forgot you guys are on that. I've been working. It hasn't been fun. Do you have any plans during the week, or you just relaxing so far?
To catch up on a lot of schoolwork. I've been kind of slacking because of midterm. So yeah.
Understandable. I don't miss my 10 season. All right, so in this kind of session, it's pretty light until the end where there's a bunch of exercises. So it might be kind of boring at the start, but hopefully we'll get you guys to the exercises as soon as we can, just for it to be a bit more interesting. There's like a simpler one like halfway through, but again, like the most interesting parts of it are at the end. But yeah.
Sorry.
Do we get to see a pet, Fanny?
It's kind of big for me to lift up, and I'm using like my laptop. But
Aww.
if he's rolling, can you guys see him?
Oh my gosh.
Say hi.
Adorable.
He doesn't like it when I lift him up. I want to let him out of the steady.
Yeah, my dog doesn't like being picked up either. It's usually bringing him into the bathtub, and he does not vibe with that.
Oof.
Yeah, no worries. Actually, looks like this one might be a bit shorter than the other ones. So hopefully we'll have some time at the end. Try to just answer some questions, or even like leave a bit early. But again, we'll have to see how it goes first.
Sounds good. How are you guys doing, by the way?
I'm exhausted. How are you?
I feel that. Yeah, the start of reading break has been a bit of a, I don't know, I guess trying to take it easy.
Yeah, no, it's good. It's always good to try and reset because it doesn't get any easier in the second half. Can't believe we're almost halfway done this.
Oh yeah, I guess with Schulich Ignite in the semester.
Mhm.
Yeah, it went by pretty fast.
Yeah, it's crazy to believe it's already like November 8th.
Yeah, no kidding.
Oh my gosh. Whoa, it's terrifying. Well, I don't know. I guess at least the end of the semester is coming up pretty fast.
Yeah, I guess it's really only like a month left, actually.
Yeah. Gosh.
Oh my gosh. Whoa.
Right? Like
Wait.
I have a month and like a week left of my internship. Oh my
Oh
gosh.
wow.
That should be fun.
Gonna rip by too.
Yeah.
Yeah, I feel like time has gone by so quick this semester.
Say that again. It's been flying. There's so many different files open right now. I'll close them all. Hope for the best. Looks like it's almost 6. Weird because I haven't heard anything from AJ yet, but hopefully he's present. So 6 o'clock.
We still have like 2 mentors who haven't showed up. I was just gonna wait for them first.
okay.
I think one of them is joining right now. I'm not sure about a bud though. I don't know if he's joining.
So cross your fingers and hope for the best.
Yeah,
If not,
I'm gonna let everyone in. I'll just we can figure out something on the go.
Oh, okay. Doing all of that. All right. All right. Hello, everyone. Welcome back to another week of Schulich Ignite. I was going to wait a minute or two for people to trickle in. Hopefully, we'll get a few more people, and then I'll get going with this week's content. How is everyone doing this week? Hey, Mark, how are you? Good. That's awesome. So if I'm sniffling a lot, it's kind of cold in here. Okay, that's great. I'm glad people are doing good. Did anyone do anything fun over the weekend? Go anywhere? Resistance. Need I say more? Ooh, I watch basketball. I like basketball, but I'm kind of a nerd. I watch a lot more esports than I do real sports. It's terrifying. Okay. All right. Ooh, okay. Sounds interested. I watch a lot of CSGO and League. I've just been getting back into CS because of the major and stuff. Okay. So we have 26 or so people. I'll give in to like 6 or 2, just because I know sometimes people are a bit late, but we'll pick it up soon. Alan, watch the terrifying amount of anime. Well, my first question is what anime is, but it slaps. I watch a lot of anime too. My favorite team. Ooh, I don't know. I used to cheer for Liquid, but okay, we got over 30 people, so I'm just gonna jump into it and get started with content, and then hopefully we don't leave too many people in the dust here. So, all right. So again, this is session 4. Schulich Ignite. It's not being recorded, so please get on that, and then of course, if someone could link the slides in the chat, that'd be really appreciated. I realized I'm not actually showing the screen here, so If I could just get permission to do that from AJ, that would be great.
Yeah, 1 second.
Okay, thank you.
Yep, you should be good.
Awesome. Okay. So after that, let's get right into it. So first and foremost, if we could get you guys to fill out a quick feedback form just to see how we're doing and kind of decide how we should develop content a bit in the future. If you want to go click that link, if I could get one of the other mentors to link that in the chat too, that would be absolutely fantastic. And yeah, if you just have a few minutes to do that, we'd really appreciate it. We want to make these as engaging and as good as possible, just because it's a lot of time invested on everyone's part. So maybe we can improve it is worth doing. So just to take a quick look at what we'll be learning today, we're going to be covering up methods and just wrapping up a bit about that. I'll talk a bit about inheritance. We won't go into too much detail, but this is for those of you who might have some programming experience but aren't familiar with like object-oriented kind of stuff. And then lastly, we'll talk about pie game sprites, which is kind of how images are rendered in games and how we can do this for the game that we've kind of been developing so far. So let's just kind of jump into it here. All right, so just to kind of refresh what we covered last week, a method is like a function, except it has access to member variables of the object. It's defined within a class, and it helps us to keep our code organized. So instead of always having like general methods that we call into things, we want to associate it with an object. And that way we can just deal with the object whenever we want to do that. It's kind of the difference between operating on SAM here and then just passing in some random function on the object instead. So, all right. So just a quick reminder is that the self keyword is key, or it is king when we're dealing with classes. It's pretty much everywhere. You need it in every method declaration right at the start of the parameters there. And then of course that also ties in with like the init method or the constructor. And so it's just something to keep in mind and keep at the top of your mind while you're working with classes and developing code with it. So one thing that we'll be talking a bit more about today is how we actually call a method. But one thing to also keep in mind here is that basically in your class definition, you want the self keyword, but when you're actually calling the method outside of the class or on an object, you'll already have it pre-cooked. So all you need to pass in are the other parameters. On this case, it's just X and Y. All right, so let's talk a bit about how we might access other methods from within a method of our class. So we've talked a lot about self and how it gives us access to like other variables in the class. Well, we can also use it to access other functions, or I guess I should be using the word method inside of our class. Here, for instance, we have the ball class, and we've kind of combined the move X and the move Y functions to kind of build a more useful function with move diagonal. So if you wanted to do some like logic with handling direction, you could use these as like helpers. And then if they're moving in both X and the Y direction, I could use this move diagonal function. And just kind of illustrate that it does both at the same time, I've coded it up here. And so we just have a quick little code snippet where basically this loop runs 10 times. And it moves in the diagonal direction, and it increments it by 1 with each iteration of the loop. And then it just reports the X and the Y values. So if we just run this and kind of see our terminal output here, you can already kind of see it there. But basically both the X and the Y will be incremented, and we just have to call the one function to do that. As you can see, that code is exactly the same as in the slide. We're just moving X and Y once for each kind of call of the move diagonal here. So let's just jump back to the slides here. So without further ado, we have our first quick question here. And basically your job is to figure out how many times self is missing from this class. I think you'll want to read this one pretty closely because they might just keep popping up. So yeah, I would just recommend that you guys double check your answer before you fire it in and submit. All right, to anyone who just joined us, we talked a bit about methods and how to call methods from other methods. Again, you just use the self word and you can access other variables from it. Okay, this is probably our most contentious poll yet, so I'm a bit excited to see how it goes. Does anyone have any questions in the meantime, or any questions about what I've talked about? Any questions about last week's content? Is anything at all? I would encourage you to just fire away. But all right, so it looks like most people have answered the question here, so we can go ahead and end that. And then I'll just be kind of walking us through the solution by actually just patching this up and getting it to work on our own kind of code here. So here we have fruit, and you can see that the linter is getting mad at us because it's not even working. But just to actually kind of be a proof of concept, I'm just gonna find one really quick. So if you want to refresh of a constructor, you can just pass that arguments to the init method here. Again, we can emit self, and then this will give us a fruit object that's named apple. And so what we want to do here is just make sure that both of these functions work. So we'll call that. As we're kind of patching it up here, we'll keep a count of how many times we need to add self to get this working. But first, we're just going to want to run this. So you'll see that it doesn't work. It basically needs a additional argument, but none is given. So basically what we need to do here is add self right here. And of course, we also need self in the constructor up here. So already that's 2. And then of course, this is just another method belonging to the class. You can just kind of tell from the indentation here, it lines up with the rest of them. That should also be included in this class, and it should also have self here. So another kind of note here, we have 2 so far, or I guess that's 3 already. We'll add in self.byte. That was just what we were talking about. To call a method from the actual class, you need to add self in there. So I believe that brings us up to 4. I might be keeping count wrong. I will do a last comparison at the end here. And then another thing to kind of keep in mind is that if we actually run this now, I will see that init is missing color. Oh, actually just, it's my bad here. So I have fruit name and it's red. So our constructor should work now. And we'll see crunch twice. But if you're actually accessing the kind of variables here, if I wanted to do print, I hope I'm spelling it right, yeah. You'll see that has no attribute color, and that's because we need to add 2 here. So otherwise, we're not really doing anything without the self here. This variable just kind of gets lost and it gets booted out of memory. Function there. So with that done, we have made all the adjustments we need. And then I guess if we want like a quick tally, we can just do a quick comparison. So this is like really hard to see, sorry. So we have 1 at the top, we have 2 more for that. So it's just 3 alone in the init function. We have 2 in the int function, so that brings us up to 5. And then we added 1 to byte, which makes it 6, which is the most popular answer. But I figured if we cover them all just to patch it up and get everything working. So So anyone have any questions about that exercise there? Or any questions in general about methods, classes, anything? Okay, I don't see anything, so I'm just gonna keep moving on. Next, we want to talk a bit about inheritance. What inheritance is, it's actually this kind of fundamental concept, but to kind of illustrate it, we're going to be pretending that we're programming our own version of Pokemon. And basically what inheritance allows you to do is to take all the variables and methods from another class that you've already like programmed, and then you can extend the functionality of it. So you can add more variables, you can add more methods, but if you're in Java, you might have seen like a parent-child analogy, but it's always kind of like stuck for me, or helped me think of it as just like building on something else. So how this is kind of best illustrated. I'm not sure how many people we have here playing Pokemon, or if that was like a my generation sort of thing, but Eevee here, you can basically give them like an elemental stone, and then they can get like an expanded move set based off of that, based on like the different like elements or types. So basically we have a fire type, like an ice type, and a green type, or a grass type, sorry. And they all kind of build off of the original definition of Eevee here. So they all have a name, they all have a type, and then they all have like the really basic moves that all of the Pokemon kind of start with Growl and Tackle. But then you'll see in the elemental types here is that each of them kind of has their own additions onto the Eevee. So we have Ember, we have Fire Fang for the fire type one, and then just kind of like the associated extensions for the other types. But kind of the key thing to keep in mind here is like how many times we have to write out like the actual name, type, Growl, and Tackle declarations if we define all of these classes separately. So for example, you could just have a class Eevee, and then you'd include all of that. And then you'd also have these 3 other classes, which are basically just duplicates of the Eevee class, each just with the added methods on. But like the reason that this is useful is because instead of having 4 files and like having to change all 4 of them whenever we wanted to change like the implementation of like Tackle or Growl, we can just define it once in Eevee, and any changes we make will be carried over for us. So I'll kind of see that here. So inheritance, as I said, it allows you to build off and extends the functionality of the original. And then that way, sorry, I'm just going to get rid of my notifications here. Sorry about that. Okay. But basically, you can build off of a class you already have. So in this case, we build off the Eevee class. And just a quick note on the syntax is when you're actually defining the class, you just pass the class that you want to build off of or inherit from as kind of the parameter of the class definition. I say that kind of carefully because it's not like a true parameter, but basically you just need to know that it goes in the brackets after you define the class. And so you can see that instead of having to write out name, type, Growl, and Tackle, like each of the 3 other times for the extensions or like different evolutions we have, we can write it once in Eevee. And then as long as we inherit from Eevee using like the kind of parameter Eevee, then we can basically take what Eevee has and grant it to each of the different types and build off of them. And then that way, if we don't have to write the same code all those different times, we only have to write code for each new type we want to implement. So I'll be working with this a bit more, and you guys will to try it out. But does anyone have any questions about like the concept of inheritance or how it is implemented? Okay, nothing yet. So, okay. So I'm just gonna move on here. So when we actually go and use inheritance, it's because we kind of had like a really visual example. We're just going to talk a bit more about it in terms of code. So again, EV is kind of our base class. We have the images up here in case you don't really know their names that well, but basically we have our basic implementations. And then one thing that is super important in terms of like inheritance is this line right here. Oh, okay. It's basically the super with the brackets there, dot, and then underscore init, underscore. And basically what happens when we call this super dot init function is that we're basically saying, hey, all of the setup we did in like the parent class or EV in this case, all of the work we did in this init function, we want to carry over the exact same thing and do it for Flareon or the child class as well. So when we actually call this, it goes up here. It assigns the name and the type of EV, or in this case, Flareon, and then to the name and type passed into here. And then it just proceeds as usual. So then I would define Ember and that sort of thing as well. So just the important thing about this is that by using inheritance and by properly applying this super function with the init here, you get to use all of the methods and all of the class variables from EV with just a tiny bit of overhead here. So it might seem a bit like redundant or overcomplicated right now, but I promise that once we start to work with this a bit more, you'll understand how it works much better and hopefully be really comfortable with working with this, because it's really fundamental to what we're kind of going to be working with later on. And so now if we actually wanted to use some of this code, you'll see that if we wanted to access the name, which was only ever defined in EV. So if we go back here, self.name, and this assignment that happens here, it only ever happens in the EV class, but we can actually use it when we're accessing Flareon. So that's probably the best way to kind of illustrate that, hey, we can actually access these things, right? So now if anyone has any questions, not a good time to speak up, but I talked about the variables, but the most interesting or most useful part of this is that I can also get methods, right? So tackle, again, was only ever defined in EV, but when we define like a Flareon, we can use tackle, or Flareon can use tackle as well, even though it's like kind of separate from EV. It just builds off of it, and that's how we get that additional functionality cooked in. And so without further ado, you guys will actually hopefully get a bit of an opportunity to practice this. And we're just going to split off into an exercise for 15 or so minutes, and you'll get to define your own EV class. I'm just going to link the file here that you'll need to download in chat and kind of extend off of. Just make sure that you actually import EV so you can build off of it. And then we'll meet back and I'll show you guys how to implement it after. So thank you.
Hey Dylan, would you be able to join Rekt Room 2? I don't think Abud's here today. So
Okay, yeah.
yeah, thanks. Just give me 1 second, guys. I'll put you guys into Rekt Rooms in a second. Jessica and Jaden, you guys should be assigned to breakout room, so I think you should be able to join. But Steve, do you remember what breakout room you were in last time? You could just, if you could put it in the chat, all right, 5, sounds good. 8, you should be set. Jaden, I think you should be able to join as well. Just hit the breakout room button in the bottom of your screen.
Okay, welcome back, everyone. Hopefully you all managed to do that exercise. I feel like it was a relatively simple one. It's more of like a proof of concept than we usually do, but I guess I'll just get started on how we might actually go ahead and implement this, and then we can cover that quickly and just kind of move on from this and jump into the more interesting topics we have lined up. So just to get kind of started on this, one thing that you I kind of drilled in before is that you need to pass in whatever you're inheriting as a parameter. In this case, you want to take an EV. And then, of course, Visual Studio Code will get mad at me and say it's not defined. And then to solve that, we'll just have to use our past knowledge and import that. But after that, we're good to go, right? So I'll start with the constructor here, because I think, yeah, it's required. And the arguments we're going to have this self, name, and type. And then basically, if we want to do what I was kind of mentioning before, where you take the parameters here, and then you pass it off to the superclass to like handle the actual initialization for you. And so basically how we do that is we do super, and that's basically saying, hey, I don't want to deal with the current class I'm in. I want to talk to my parent class or EV in this case. And then we can call the function there. So we can just pass in name and type. Should handle that for us. I guess one thing that kind of shows that we didn't try this out in code before is that the type keyword is actually reserved. So I'm just going to do a p type just for Pokemon type. That's break around that. All right, and then we kind of course, the whole point of this all is to like build off of what we actually had in EV instead of just carbon copying it like we are now. And so we'll want to define like a specific move. Keyword. And we can kind of do whatever we want. I'm just going to do self.name. And that way, basically, no matter what Pokemon calls this, it'll always bring in the name and say that they used the move they did, instead of always kind of referring to just Jolteon. And that's kind of how you get like a more general programming scheme. It's important that you do this in EV though, because otherwise it might be calling like Flareon. For example, EV, if you just did, for example, Scroll here, it won't actually be aware of like the name or the type of the Pokemon that's calling it. So it's just something to keep in mind when you do your own programming. But yeah, that basically covers the exercise. It was super simple. So I hope you guys are able to finish it. And we're just going to be moving forward with some sprites here. So let's talk a bit about what sprites are and why we want to use them. So a sprite is basically any object on the screen that uses an image when it is drawn. So if we kind of look back on the exercises we've done already, they look like super ancient. All we have is just some colored boxes, right? But what I'm really kind of in awe of these days is how graphics are so realistic and how they kind of bring images into it, right? So a sprite basically makes it really easy for us to bring in an image, and then we can transform and like work with that image using a rectangle that we've been really familiar with and working a lot with so far. And then some important things to kind of note about the sprites class is that we'll also need to implement a draw method and an update method. And basically, anytime we want to make our own sprites in Pygame, we're going to take the concept of inheritance that we just learned, and we're going to basically take all of the code that Pygame has for us, and then just build off of that using our own image, basically. And so it makes it a lot easier to work with. And we'll just be talking a bit more about how we actually do this with our code here. So what is a sprite? Well, in computer graphics, it's kind of like a blanket term just to mean anything on the screen that is like drawn from an image. I guess they said that it can move. It doesn't necessarily have to move, but usually it's a lot more interesting when it does. When you play a 2D game, for example, all of the objects you see on the screen are sprites. And then just to bring in some of my own computer graphics knowledge is that in 3D graphics, it's actually 2D images too, but they have some like really interesting math going on to kind of simulate a 3D environment and patch it into a 2D screen. So if you're that sort of thing kind of interests you, or you're kind of curious about what I'm saying, you should go into comp design, take some graphics courses. It's pretty interesting actually. So to kind of bring myself back to reality here, I'll be talking a bit more about how sprites work in Pygame. And basically one of the more important methods that we're going to be doing or working with is this get Rekt method. It creates a rectangle with the same width and height of the image. And basically it can help to visualize it like it's done here, where get Rekt returns like this rectangle here within the window that represents your image. And it's important to note that any transformation you make on this rectangle will also kind of carry through on the image. So if we use get Rekt and get the rectangle, then we modify the X or Y position, for example. Basically this image here would move. And that's the same thing for width and height. So if we wanted to stretch this owl out, we could do so by getting the rectangle with get Rekt and then changing the width to be higher than what it starts as. So let's just talk a bit about how we actually make our own sprite class. And I'm going to walk us through this as well. But just to start off, we don't need to worry about all of the beef down here. We're just going to be focusing on what we did already, where we kind of take the class, we extend from Pygame or like Pygame's sprite definition. And then to actually get access to all of the interesting things it does for us, we need to call like the super init method. And then that will basically help us get going. So it's kind of a proof of concept. I'm going to be working through actually writing a fairy class as we do this example. So some demos here. I'll make a class. Py. And just to review that, anytime you kind of work with your own class, you want to import it here. So, or you'll want to make it in its own file. So I'll just get access to Pygame. We're going to preemptively import it there. And then we're going to define our fairy class right here. One thing that's kind of can throw you off is that when you're just defining a class that doesn't use inheritance, you actually don't need to throw these brackets down. In fact, if it might even get mad at you or take them out, but only ever when you're like actually building off of it do you like really need this. So I'm going to take class definition from Pygame and inherit from it. And then we're just going to once again do the constructor. And you can kind of see it builds off of this for me automatically. My mouse came unplugged, so I'm just going to fix this up with my keyboard. But we don't need to know all of this, the complicated stuff. We just want to know self. And then super init as usual. Just to make sure that we've done this right. I can switch windows, but give me a second. I just need to plug something in. What is that? Sorry about that. I just had to move my computer within this last week, so forgot to plug in some stuff. But I'm just going to verify that we did this correctly. So we don't actually need any arguments to pass into this init function, but we have kind of the basics of making our own sprite class built in. And then as we kind of move forward here, we're going to add more to it. But let's talk about how a Pygame sprite interacts with the actual main classes or games that we've been writing. So generally, when we make a sprite class, we need to define both an update method and a move method. And basically what happens here is that update, as I've kind of done with some of the demonstrations I've had so far, is that instead of having all of the logic for like a sprite or a player, for example, in like the main logic or the main game, we can move it into the class, and then we can just call update from the class, and it kind of minimizes or like simplifies the actual main code a lot. And then the move as well as another method that kind of comes pre-cooked. And I think we'll be using this just to update the coordinates and actual position of the sprite. So before I actually go in and get our own sprite in the game, we'll need to actually download an image here. So if you're following along, I'll just drop this in chat quickly. But basically, we'll want to make a folder named assets, and then we'll talk a bit about how to actually get this in the scope of our game and draw it in a second here. So I'm going to put my IDE, and I'm going to press that link. And we'll just talk about how to download it. So I'm in Firefox, but regardless of browser, you should be able to right click, hit save image as, just navigate to wherever you're working. I happen to already be there, so maybe I'll jump out. Session 4. You'll probably want to make a new folder, name that assets. In my case, I already have it. And then you can just go in there and hit save. I already have it, so again, I just need to overwrite it, but bring that in. And then it's important that you kind of have it in the same space if you're following along, just so that you import it properly. I think someone, okay, good. And so to actually load it into our game now, we just want to use this kind of boilerplate code we have here. So we actually need to import the OS to work with paths and make this a bit easier to load. And then we'll want to use the Pygame library's image.load function. And this will look for fairy.png in the folder we just had. And then it will basically take our image into a Pygame rect that we can use, and that I talked a bit about before. So if we just go into this, one thing that you'll want to make sure of is that however your fairy.py file is in like the same folder as the assets folder. So I'm just gonna give myself a second to get figured out here, but let's see that I have assets here, and I actually don't have my class named yet, but we can go ahead and do that here. Just the way VS Code works is that sometimes it doesn't go exactly where you want it to, but you should have assets and fairy in the same kind of top level folder here. So if you're looking at it from Finder or just Windows Explorer, you'll see your piece of code and then the assets folder here. So I think I completely lost my code from before. How did this happen? Okay, sorry. Let's copy. Okay. So basically what's new here is our import of OS and then this function here. And then I believe if you just want to use the direct path, it wouldn't be too hard, but just to stick with the exercises, I won't even show you how to do that. And then to actually go ahead and then take the image that we've loaded and make it into a useful Pygame object. We're going to take these 2 lines here. So we're going to call .image.load with our image location and then convert it to alpha. And this just makes it so that if you have a transparent background, it'll actually kind of consider that when it's drawing it. The fairy is a good example of that, actually. Then we can also do an assignment here just to kind of make sure that the image rectangle is the one we're working with when we call any transformations on our fairy class itself. So that makes life a bit easier for us. Then we won't actually see this in action right away, but if I bring in like a main folder and import fairy, we'll actually get a good eye of how this all kind of fits together. But before that, we're just going to move to a quick question. So what's missing from this basic sprite class that would make it not function properly? Hopefully this one will be answered pretty quickly. I guess there are a few kind of viable answers, but only one will actually stop the code from just straight up not working. So does anyone have any questions at this point either? Okay, looks like we're good. Pretty much everyone said that, hey, the super important, like super init constructor call is missing, and that's exactly what's going on. The other functions, you generally will pretty much always have them, but they won't straight up cause things to not work properly and your sprite to not actually function properly if you don't include them. So you always need to make sure that you include it, just like we did in our earlier definition right here. All right. So let's talk about Sprite Groups. Basically, what Sprite Groups do is they take a bunch of sprites and they group them up together. And this is most useful when you have kind of explicit copies of one another. But it's good to always use them just to help make life a bit easier. And down the road, when we work with collisions, they'll be really useful as well. So all sprites that we're going to be working with should always be in a sprite group. Again, even if it's just one, how you do this is that you just initialize a sprite group with pygame.sprite.group, and then you take the variable and you call the add method on it with the sprite that you want to add to the group. It's nothing super complicated. So if we wanted to do that for the fairy class we just defined, I would first create a fairy object, just the fairy constructor. We'd create the group with the group constructor, and then we would add our fairy to the group of fairies, just as it shows here exactly. So generally, you will want to do this in the setup because you'll actually be working with and drawing your sprites later on. So you want to make sure that they're always present for that, or else Python will cause some pretty nasty errors. When you actually get around to drawing the sprites, one of the reasons that we actually say to use a sprite group is because it makes it super easy. Basically, all you have to do is take your sprite group, call draw, pass in the screen like we've been doing with the rectangle, and then it should show up for you wherever the images or the sprites rectangle actually is. Again, we're going to see this kind of in action soon, so just stay or just keep your eyes peeled. To actually update the sprites, again, it's very simple. Instead of keeping all of the logic in the main loop or this while true loop here, you can just call fairies.update and it'll take care of it for you. So let's go into the class, call them update method that you defined before. And again, this just makes it a lot easier to work with and read your code later on. And without further ado, we're just going to be moving into our second exercise here. So what your job is to do is to take what we learned about the sprite groups and defining a sprite class like I showed you, and then actually kind of put this in practice and get your first image in loaded into Pygame here. We recommend that you take last week's and you just kind of build onto it. And that way, as we kind of work along with our platformer and develop on it, you might be able to notice that this is looking a lot like a platformer. But so I'm just going to send you out to the break rooms and be good to go.
And make sure you join your breakout rooms, guys.
All right, it looks like we have everyone back. Hopefully that exercise went well for you guys. I realize it's quite a big step up from the last one we did, so I'll just walk us through it here, and hopefully we'll have a bit of time at the end for any questions. To start, we'll just be working off of last week's exercise, or what we finished off with. I just copied the platform, the player, and the main class, and I just brought it into my session 4 folder, but you guys can probably just work in the same folder. And just to kind of see what it looks like, we have this box here, and basically what we did was just get it moving. And what we want to do now is to just give this box some form and some life by associating a sprite with it. So the first thing that we'll want to do here is
Hey, Dylan, it's not sharing your screen.
Oh my gosh. Okay, thank you. Sorry, I look like an amateur today. Whew. All right. So I brought my platform, player, and main class from last week's session, and I just brought into my folder with the assets here. So I can just keep the same folder. And what I'm gonna start working with first is the player one, because we just need to bring in the sprite integration. So I will want to make sure that we import it. And then we've been talking about a lot about inheritance. So that's just what I'll start off with. I'll bring this in and say that, hey, we want to extend it. Okay, so let's see. Hopefully it should work out for us. There we go. Okay, so we're extending off of pygame.sprite. And one thing that we always need to do when we do this is call that init from the parent sprite class to help us get going. And then we'll just have to bring in the methods we had from the slides here. So again, when we load our image, we're going to get our location. We're going to load it with the pygame.load. And then we're going to get the rectangle. So what I'm going to do is I'm just going to download the player asset. I dropped it in the chat before, so I'm just going to go ahead and download that really quick. Save that. Okay. Just to save some time, we can go ahead and kind of just build off the code here. So I'm just going to copy it and explain it kind of as I go. And this is all happening in the init one. So quite a bit of warnings here, but you'll see that you might have to import OS as well, just to load the asset. The thing that we want to make sure is that we're doing the actual player PNG here. Yeah. And we should be pretty much good to go. And then we will need to kind of change how our player classes worked within the main one. So I'll move on to that. But this should just be enough to actually get our game kind of loaded here. So you might be able to just get rid of this self.rect one here and just replace it with the images rectangle. This is really important because, as I said, this allows you to access the transformation of the image. So anything you do to that, I will carry over to the image as well. So make sure we do that. And then the load method, there's not much to explain here other than just converting it to alpha so that we don't see like a white or like black background behind the player here when we actually bring it into our game. So I'm just going to keep the rest of this logic intact and we'll move on to the rest of the implementation here. So in our main class, we'll probably need to change how it first initiates, because we instead get the rectangle from the image and it loads into the top of the screen. We don't need to pass it in a rectangle anymore because this is done, as I said, when the image is created and when we load it in. So I'll go to the top here, set the initialization of our player. We should no longer need this. Hopefully, if I load this up, we'll be able to see it. Okay. So it's getting mad at me and saying no such file or directory. So It's probably just not loading it from the assets correctly. Pathing is always kind of tricky, so I'm hoping that we can resolve this without too much pain. But it's hard. Okay. I don't have any suggestions. Oh, okay. Thank you. Oh, for that first. Okay. All right. So we see it in the corner, but not getting the right image here. I'm just wondering if this is because how I draw it. Okay, no, it's definitely the case. So basically what we have done here is that we've loaded it in and we have it in the top corner. But we actually didn't follow the instructions for getting the sprite group and getting that working yet either. So again, if we just review this really nice slide here, we first need to initialize that. So we have our player. Now we just need to add it into a sprite group, even though it's kind of on its own. And then I just need to draw it using the draw method it has there. So I'll go ahead and implement this. So first I'll create my player group. We'll do Sprite group. Okay. And then of course we just need to add the player to this group. So we'll add players. And then the reason why we get like a white image before is that we actually didn't update how it draws. So it's still drawing a rectangle, just using the dimensions of the player, and it's just drawing a white layer there. So we can go ahead, take this out, and replace this with players.draw. If everything's working correctly here, we'll see it. Again, I'm always forgetful when it comes to drawing this. I just want to draw it, but you need to pass it in the screen, just like we did with the rectangles. And then finally, we have our player in the game here. It's not very interactive because we don't have any animations. But if you do want to go look at the slides and get some animations going, I think that'd be really fun, and it's pretty challenging as well. So if you have a bit of extra time this week and want to get your hands to do this more programming, that's a really fun thing to try out. And then just like a final closing kind of admin thing here is that next week we're going to be working on an example where we basically take what we have right now and build on it to start building a platformer. So if you guys could just take a moment either right now before the class ends or as it kind of wraps up here to go click these links. I'll copy them into the chat. But basically you need to take the platform.py that you have from your updated kind of game here, and you can just replace the code with the code we have from the slides. And then it actually draws like a grass asset as well. So you'll need to download it just from this link as well. So I'll copy that into chat and you guys can take care of that. And then as soon as you finish, you're basically free. I have nothing else to teach you guys this week. So if you could please just spend a minute on this quickly so we can just get straight into programming next week. That'd be super appreciated. I just want to thank you guys all for your time and investment into this so far. I think as we kind of start getting into the more advanced ones, it'll be trickier, but I think you'll be really blown away by what you can create and kind of have fun with. So again, thank you for your time. Please just follow that one slide, update your platform code, and then just add that image to your assets folder. They should be linked in the chat. And then next week, you can just get going and start coding right off the bat. So thank you guys so much for your time. We'll see you again next week.